Okay, so now what we're going to do, and I'll just show you the company that I'm working with here, International Biomass. These guys have a proprietary, so they're primarily wood processing, as it shows here, and they're doing pellet manufacturing, and they're using plastics, specifically high-density polyethylene, as a binder in a wood pellet that is basically more or less a waste energy product. So let's take a look and see if we can add some value to this plastic without, and process it locally without breaking the bank. Okay, so now if we go out, and I'll tell you right away, if you go out on the market, you will not get $1.25 per kilogram for this kind of stuff. What you're likely to get is something more like this, 3 cents per kilogram baled versus 6 cents per kilogram shredded. Why is the shredded more valuable? Well, because what happens is you've got chunks of wood, little chunks of plastic. They get combined into a stream and then extruded as a pellet. Kind of hard to do that with a whole big old bale of plastic. So it's got to get shredded to begin with as part of the process. Now, to answer your previous question, what's embodied energy? Well, embodied energy is going from the baled to the shredded. Someone or something has to do the shredding. So let's look at a 75 horsepower, and sorry, I'm going to go kind of fast here, 75 horsepower engine, and let's say it can process 1 ton per hour. So we're going to just see what it costs to run this machine per hour and see how, like, in an hour, how much money we have to dump in energy into this thing to get it up from 6 cents a kilogram up to 3 cents a kilogram. Let's see if we can do it or not. Okay, so 75 horsepower. How many watts in a horsepower? 746 watts. And let's just run it for 1 hour. Let's run it for 1 hour, and we're going to put 1 ton through it. We're going to assume that we can put 1,000 kilograms through the machine. And so now we've got watts, and let's get this in kilowatts. So let's see, 1,000 watts is going to be 1 kilowatt. So now so the horsepower cancel, the watts are going to cancel, and we're going to end up with kilowatt hours. So let's go back to our calculator. So if we're going to run this machine for 1 hour, 75 horsepower times 746 watts per horsepower divided by 1,000 watts per kilowatt equals 50, let's just call it 56 kilowatt hours. And what's that going to cost us? What would we say, a dime per kilowatt hour? 1 kilowatt hour times 0.1 equals $5. Okay, so $5 to run that thing for an hour. Now, there's also going to be a demand charge that I did not include. We'll get into that later, but $5 per 1,000 kilograms, right? So how many dollars per kilogram is that? Well, $5 divided by 1,000 equals half a cent. Not too bad. Not too bad. So we, with 1/2 penny, no, that's assuming that the machine keeps running and we can in fact process a ton per hour. If it's less, if we, for whatever, the thing breaks down, we're only running 250 kilograms per hour, we're not going to make as much money. But 0.5 cents, what that ends up with is 0.5 cents per kilogram. Is that a reasonable profit margin? Are you willing to put 5 cents per kilogram? I mean, basically you took this from, you could have sold it for 3 cents a kilogram. You stuck an extra 5 cents a kilogram. Well, you probably had to pay the operator to run the thing. That's going to cut into it as well. But half a cent per kilogram, I'd say that, at first glance, that might be not a bad deal because you've just doubled the value of that material by putting some embodied energy into it. So does that all make sense? You might have to ask yourself, where did that energy come from? Well, obviously running that machine, you're on the grid, there's probably a coal-fired power plant burning somewhere, there's a wind turbine somewhere, there's a hydro dam somewhere else, there's solar, so all of that primary energy is coming in to do some processing. But that's an example of a manufacturing or industrial process that puts embodied energy. You could run the same thing for glass, you could run the same thing for metal, you might even run the same thing for compost or biogas or what have you, but every single recycling technology economic problem that you're going to run into is going to come down to math exactly like this. We didn't include storage, et cetera, but there's kind of your embodied energy going in. Okay, we're right at noon. Any questions at all on what we just kind of went through? Yeah, Priscilla. What is what? Oh, baled, I'm sorry. Baled is, it's a big, so it, over at the recycling center, and I promised to post these pictures, it's just like a big straw bale, except it's a plastic bale, and there's a compactor, so all of the plastic goes into the compactor, squishes it down just with a big piston and cylinder, and then there's some metal straps around it that then hold it like you would see like a straw bale. The shredded is like snowflakes of plastic. And we'll do a field trip here in a couple weeks, run over to the hive, and I can show you examples of both. We've got baled, and we also have some shredded that we've run through this machine. So here's how you compete with capitalism. That's how we started our discussion. These are the numbers the capitalists are doing all day long to decide whether or not they want to invest in your little business plan. So anyway, all right. Well, I was really looking forward to that lecture because, at the end of the day, it's putting your money where your mouth is, and is the thing going to make sense financially or not? And we just did 2 or 3 little examples where, you can take this same skill set and apply it to any recycling technology challenge. Super. All right. Well, I feel better. Hope you guys do too. Shelley does. Good. That's all that matters.